Hello again. It is the end of the day. Let's see if I will make any sense when I talk. All right, I believe this is going to be the last video for weighted voting. Okay. Sequential coalitions and pivotal power. So in the last video we talked about, I think it may have been 2 videos ago, we talked about what coalitions were, how they were just like subsets of all the players in a weighted voting system. And then we talked about coalitions. Wait, I just said that. We talked about what coalitions were. But those coalitions, if you remember, they were just groups of people. There was no order involved, right? So in a sequential coalition, you're talking about a coalition, but one in which you're paying attention to the order in which players join. So when you pay attention to the order in which players join, the player who provides the votes that make the weight of the coalition go over the quota is called a pivotal player. So this is a little different from a critical player, because remember, a critical player, you just had a set of people and those people together had a certain number of votes, and the critical players were the players who had votes that if you removed them, the coalition no longer made quota. So the pivotal player is the player that you add to put the coalition above quota. And here the order matters, right? Okay, so unlike critical players, right, where you could have more than one critical player in a coalition, there can only be one pivotal player because of the definition of pivotal player, right? You start, you have a coalition that members are the players are added sequentially. So there's a first player that's added, then a second player that's added, then a third player, and the player that provides the votes that cause you to meet quota is the pivotal player. So let's just look at some notation here. Here is the notation for a sequential coalition. Notice the, what would you call these? I don't think they're called arrows. They're these things. What are these things called? They're some kind of bracket. I don't know what they're called. I just realized, or if I do, I can't think of it right now. But these are the notation you use around a coalition when the coalition is sequential, right? So remember that we used the curly brackets just to, encompass a coalition in general. When you see these little angular brackets, that is a sequential coalition. So that's when you have a first player, a second player, a third player, and so on, or first, second, and third players are added to the coalition in order, right? So player one doesn't have to be the first player, but there's always, to make this coalition, someone joins first, and then the second player, and so on. Okay. So in this sequential coalition right here, the first player to join is player 2, right? So player 2 was the first player to join the coalition. The second player to join was player 1, and then player 3 joined, right? So they joined in that order. Okay. So we know what a sequential coalition is, and we know what a pivotal player is. All right. So there is another power index. So remember, a power index is a way to put a number around how much influence, right, someone has in a weighted voting system. And we have already looked at the Bonzoff power index, which sort of gives a distribution of the power in a voting system. Here is another power index called Shapley-Shubik. I believe that Shapley and Shubik were both people, but I don't remember anything about them if I ever knew it. So the Shapley-Shubik Power Index counts how likely a player is to be pivotal. That's a really interesting definition. All right, so let's see how to calculate it, and then maybe we'll revisit that. All right, calculating the Shapley-Shubik Power Index. First, list all sequential coalitions. So this is very similar to the Bond-Soft power, but not the same, right? In the Bond-Soft Power Index, we listed all possible winning coalitions. Here we want to list all sequential coalitions, so all of them, not just the winning ones, all of them. That's what it says. Not list all sequential winning coalitions, but list all sequential coalitions. All right, and number 2, and then in each sequential coalition, determine the pivotal player. So you'll just start with the first player and start adding up votes until you get to the quota. And that person who provides the votes that put you over or at the quota is the pivotal player. And then count how many times each player is pivotal, very much like Bond-Soft Power Index. And then convert these counts to fractions or decimals by dividing that number by the total number of sequential coalitions. Now this is a little different, right? It's not the total number of times that players were pivotal, right? Which is what we did when they were critical, but it's you divide by the total number of coalitions, period. And that, so because there can only be one pivotal player in a coalition, right? When you count how many times a player is pivotal, you're basically also counting coalitions, right? How many coalitions was this player pivotal, divided by total number of coalitions, and you get this number that represents the proportion of total sequential coalitions in which this player was pivotal. Okay, so that is how you would do it, right? So if you were thinking about actually doing it, you would say, okay, I have to list all sequential coalitions. So there actually is a little bit of mathematics behind how to count how many sequential coalitions there are. I think I'm gonna, let's see what I want to say. Okay, because really what we're saying is we're taking a group of, say, 3 or 4 people, right? Players, let's say 4 players. That's going to be the example, right? And a sequential coalition is not just subsets of those people. It's ordered subsets of those people, right? So what that means is for, say, like the sequential coalition that's player 1, comma, player 2, comma, player 3, that sequential coalition is a different sequential coalition than player 2, comma, player 1, comma, player 3, right? So even though these coalitions contain the same players, they're not the same coalition when you're considering order, right? So that word sequential is what tells us that we care about order now. Because remember, the order in which the players join the coalition will have an effect on who is pivotal. Okay, so we need to find a way to list all possible sequential coalitions. And the first step in doing that is maybe understanding, how do we know how many there are? How many, because if you know how many there are, that is a huge help in making sure that you listed them all. Even when you're using a systematic approach, if you know how many you're supposed to have, then that helps you understand. Okay, so how do you count? How many ways are there to arrange, say, 4 things? Let me give you a intuition here. So this word arrangements, right? An arrangement is often used. So arrangement basically implies there's order, right? So you have like 5 books and you want to put them on your shelf. How many ways are there to arrange those 5 books? Well, that's asking how many orders can you possibly put them in, right? So if you have 4 things to arrange, say player 1, player 2, player 3, player 4, right? How many different orders can I put them in? So here is sort of kind of an intuitive explanation as to how to figure this out. So imagine, right? So you've got 4 players. So that means you have like 4 spaces you're going to put them in. And you want to be able to count, like, how many possible ways could I do this? So you could think of it this way. Say like, okay, I want to choose, so here's the first spot. Here's the second spot. Here's the third spot. Here's the fourth spot, right? You might say, okay, how many choices do I have for the first spot, right? I have 4 possible players to choose from. So since I haven't done anything yet, right, I actually have 4 choices for the first spot. All right. Now, it could be any of the 4 players. I'm not saying it's player 4. I'm just saying there are 4 choices, right? Those are the number of choices. All right. All right. So, but then once I've chosen somebody for the first spot, there's only 3 people left to choose from. So for the second spot, I've got 3 choices, right? Now, of course, so then we've chosen 2 people, so we have 2 left. So then for the third spot, I have 2 people to choose from, so I have 2 choices. And for the fourth spot, we've chosen everybody but one, so there's the last person has to go. There's only 1 choice for that last one. So what we're really saying is there are 4 ways to pick a first player, and after doing that, there are 3 ways to pick a second, then 2 ways to pick the third, and then only 1 way to pick the fourth. And there is another rule in mathematics that I'm not going to go into, but that says, right, if there's say 4 ways to do one task and 3 ways to do another task, how many ways are there to do both tasks? Well, there's 4 times 3 ways. Sometimes it's called the multiplication rule. We don't have to worry about the details or the names, but what we can see is that you can multiply the different ways to do each task to determine how many ways there are to do both tasks together. Okay, so we can apply that here. So if we do 4 times 3 times 2 times 1, that will tell us how many ways there are to arrange 4 things. So 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24. Okay. So there are 24 different arrangements of 4 things. Right? Here we're talking about players. So there are 24 different orders we can put 4 players in. Now, are you gonna, I should have looked at the homework. I haven't recently looked at what your assignment is for this section, and it would help me to know what you're actually going to be asked to do. So I'm going to take a moment and go look at that. Okay, that was very helpful because I wanted to know if you were going to be asked to actually list all 24 sequential coalitions of a voting system with 4 players, and you're not, right? I think you have to do one where there's 3 players, and that's much easier. But this idea of why we're multiplying, right? If we have 4 players, why are we multiplying 4 times 3 times 2 times 1 to count the number of coalitions? Well, this argument kind of should hopefully help you understand why that works, right? And so this idea of multiplying, right, 4 times 3 times 2 times 1, there's actually a mathematical notation for that, and we would write it as 4 exclamation point, right? And we would call that 4 factorial. That's 4. So 4 factorial, right? It's not 4, it's 4 factorial. And so here is that in general here. The number of sequential coalitions with n players is n factorial, right? So that just means, right, you're going to multiply n times 1 less than n times 2 less than n, right? So here is the name written out and nice typed number there for you. And then here is, this is showing what it looks like in, so first of all, n, right, is kind of like it's a general number. It can be any number. So n factorial. So just like if we had 4 factorial, we would do 4 times and then 4 minus 1, right? So notice here n minus 1. Well, we would do 4 minus 1, which is 3. And then 4 minus 2, right, which is 2. So you just keep subtracting 1 every time. So when you see something like n minus 1, that just means 1 less than n, right? So it's the number right before n. And then you see n minus 2, that's just 2 less than n. So it's number 2 before n, if you're thinking about like just a number line. So that's what that means. So if that pops up, just know that n factorial means it's the product of all the whole numbers from n down to 1, decreasing by 1 every time, right? So for instance, right, if you had something like 5 factorial, that would be 5 times minus 1, right, times 3 times 2 times 1. And you would multiply those together, and I believe this one is 120. Yeah, right. Factorial gets pretty large pretty fast. if you get out your calculator, if you get out your calculator, what is now factorial is on your calculator somewhere. Where is it on this calculator? I think I have to go into like, can I go to math? Oh yeah, go over to probability, and then go down to the exclamation point, 10 factorial. See, that's pretty big. Right? I mean, it's not like overly big, but that is, what is that? 3,628,800. Let's do one more. Let's see how much bigger it gets if we increase by 5. Whoa. So that's way bigger. If you look at this e to the 12th, what that means is like 1.3 blah, blah, blah times 10 to the 12th. So it's really this number here, if you were to move this decimal 12 places to the right. So that is a giant number. So you can see it gets pretty big pretty fast. Don't worry, we're not gonna have to worry about the big numbers, but it's an interesting thing to think about. Okay, so now that we know what sequential coalitions are, we've gone through the list of what the Shapley-Shubik Power Index, how it's calculated. We know how to determine how many sequential coalitions they're going to be. There will be, depending on the number of players, right? So n would be the number of players. Now, let me go back here. See, they didn't say this, but sequential coalitions always have all of the players in them, right? Because there's no reason not to list them, because we're gonna count up to where there's a pivotal player. But unlike the winning coalitions, some winning coalitions only had 2 players in them, some winning coalitions had 3, and so forth. Sequential coalitions always have all the players in them. It's just different, they're in different orders. Okay, so let's do some examples, and hopefully any questions you have will be answered while going through these examples. And then if not, you have me, you can ask questions too, and your fellow classmates. Okay, so let's look at example 8. Consider the weighted voting system, bleh. Okay, the quota is 17. There are 4 players. 1, 2, 3, 4. Yes, indeed. No one's a dictator. Okay, so that's the system. In the sequential coalition, okay, so here they give us one particular sequential coalition. So it's player 3 is first, then player 2, then player 1, then player 4. Which player is pivotal? Okay, so we're just going to start looking at how many votes the players have and adding them up until we get to quota or above quota. I can see right now that player 2 is going to be pivotal, but how do I know that? I'll show you. Okay. Player 3 has 13 votes. Okay, so player 3 is not the pivotal player because player 3 was the first player to join the coalition. Player 3 does not meet quota, so they're not pivotal. Okay, then you're going to add the player 2's votes, which are 9. What is 13 plus 9? 22? I feel like, yeah, because 13 plus 7 is 20, plus 2 more. Okay, so there you are. After player 2 joins, quota has been met. Therefore, player 2 is pivotal. Does that make sense? So if you go back to the definition of pivotal, a pivotal player is the player in a sequential coalition that changes a coalition from a losing to a winning one, right? Which means that they bring the votes to meet quota. So in this particular sequential coalition, right, as soon as player 2 joins, their quota is met. So we're not even going to look at players 1 and player 4 because quota is already met with player 2. That's the pivotal one. They're in the sequential coalition, but we don't care about that really because we're looking at, like, as if we're building ordered groups, right? Ordered coalitions. Who is pivotal, right? When is, who is the person that brings the votes that make us over quota? Okay, so in this particular example, player 2 is pivotal because they are the ones that bring the number of votes to meet quota. Okay, so nice question, right? We didn't have to list all 24 because there's 4 players here, so we'd already figured out that there'd be 24 sequential coalitions. We don't have to list them. Not in this particular example. But we do have to list them in the next example, but there's only 3 players here, so it's much easier. All right, so here they want us to actually find the Shapley-Shubik Power Index for the weighted voting system. All right, so let's just, the quota is 36. Player 1. All right, that player 1 has 20 votes. That's the weight of player 1, the weight of player 2. Why am I've been doing P's up until now, but now I want to do W's. I'm going to put P's back. I don't know why I want to do W's. Player 1 has 20 votes. Player 2. I think that I was thinking, oh man, have I been confusing people by using P's up here? This is just me labeling stuff, right? I just want to be able to look and, because with my eyes, sometimes it messes up. But we do know that if we are writing a weighted voting system, we put Q and then we put the weights of the players, right? Not the players themselves, right? Remember that. But for my purposes, it's easier. I want to label the votes with the player whose votes those are. That just helps me. If it doesn't help you, don't do that. Okay, so we need to find the Shapley-Shubik Power Index. Our first step is to list all sequential coalitions. Okay, so first let's use our little formula to figure out how many sequential coalitions. So there are 3 players in this weighted voting system. That means there are 3 factorial, right, which equals 3 times 2 times 1, which equals 6. There are 6 sequential coalitions. All right, so we know that there are 6 of them. So we need to write all 6 of them down. All right, so these are just going to be different ways to order P1, P2, and P3. Okay, so again, right, there's only 6 of them, so it's not too bad, but you should definitely take a systematic approach, and here is how I would do it. I would say, okay, I am going to, whoa, what's going on? Hello. Something's happening here. Okay, I'm going to start with P1. Let's just do the one that's in order, right? P1, P2, P3. Okay, so then I am going to keep P1 where it is and see, can I do any other orders where P1 is still in that first position? This makes sense to me, right? And yeah, so I could take P2 and P3 and switch them, and that is a different sequential coalition because that is a different order, right? And those are actually the only 2 sequential coalitions with P1 in the first place. Can you see that, right? Like if we couldn't write a different coalition and still have P1 in the first place, we've exhausted them all. Okay, so then I would move to putting P2 in the first place. All right, then the other 2 players are P1 and P3. So I could do P1, comma P3. All right, or keeping P2 in the first place, I could put P3. It kind of, I tried to do the P and 3 at the same time. And then P1. All right, and those are the only 2 sequential coalitions where P2 is the first player. All right, and then we're going to do the same thing with player 3. Put player 3 first, and then we have 2 players, player 1 and player 2. So we could put them in that order, player 1 and player 2. Or we could switch those 2. And those are the only 2 sequential coalitions with P3 in the first spot. And that's all 6 of them, right? We knew we had 6, and now we have 6. There's 2 with P1 in the first spot, 2 with P2 in the first spot, and 2 with P3 in the first spot. All right, so that's the first step. We just had to list all the sequential coalitions, and we have done that. What's next? In each sequential coalition, determine the pivotal player. Okay, so determine who brings the winning votes. All right, so we're going to be adding stuff here. I might use a green pen. Okay, so our quota is 36. That's what we're searching for. And our weights are player 1 is 20, player 2 is 17, and player 3 is 15. All right, I got it. I'm focused. All right, so in this first sequential coalition, player 1 joins, they got 20 votes. Okay, they are not pivotal because that's not enough. Add player 2, that's 17. Does that bring us to 36? Indeed it does. So these two together hit quota, so player 2 is the pivotal player. Player 2 is pivotal. They're the one that brought the votes. All right, next. I'm going to go to a smaller pen. Thank you. Next one, player 1 has 20 votes. All right, then we're adding player 3s, which are 15. Okay, so notice here, 20 plus 15 is 36. Doesn't meet quota. But as soon as we add player 2's 17 votes, then we meet quota. So player 2 is again the pivotal player in this sequential coalition. All right, let's do the same thing with the next one. So here on this one, I'm here now. We're going to start with player 2. They've got 17 votes. Then we're going to add player 1's 20 votes. That's 37. That's above quota. So player 1 is the pivotal player here. Right? Is this making sense? If this isn't making sense, pause the video, go back, look at the definitions, make sure you understand what the definitions mean, because it is true that once you fully comprehend the definitions of these words that we're using, then this will be relatively easy. Because if you know what a pivotal player is, you just know that you have to start adding all the votes together until you get above the quota. All right. Next one, player 2 has 17 votes. Player 3 has 15. What is 17 plus 15? 15 plus 15 is 30, plus 2 more is 32. Nope, 32 does not make it, so you have to add player 1's 20 votes to meet quota. Therefore, player 1 is pivotal in that coalition. Well, looky here, so far player 2 has been pivotal twice and player 1 has been pivotal twice. Let's see what happens in the last two coalitions. All right, here we start with player 3. They have 15 votes. If you add player 1's 20 votes, that's only 35. So nope. So you have to add player 2's 17 votes. Therefore, player 2 is the pivotal player. All right, and lastly, player 3 has 15 votes. If we add player 2's 17, right, again, 15 plus 17 is not equal to 36, right? That's only 32. And so you have to add player 1's 20 votes. I'm not even bothering adding that up. I don't care what the number is. I just know that they have to be there in order to meet quota, because 15 plus 17 together does not meet quota. All right, so look at this. Poor player 3 is never pivotal. All right, so now that we've identified the pivotal players and all the possible sequential coalitions, what do we do next? Count how many times each player is pivotal. Okay, that's easy. Let's do it. So let's see. Stop it. I'm gonna write it here. Okay, I'm gonna write it right here. Player 1 is pivotal how many times? 1, 2, 3. 3 times. Player 2 is pivotal also 3 times, right? Because it's 1, 2, 3. Yep. And player 3 is pivotal 0 times. Player 3 is never pivotal. All right, then we are going to do what now? Convert those counts to fractions or decimals by dividing that number by the total number of sequential coalitions. Okay, so we had 6 sequential coalitions. So I'm gonna write here. You know what? I started it. I was gonna abbreviate Shapley-Shubik SS, but Shapley-Shubik Power Index. All right, so we're going to take, for player 1, we take the number of times they are pivotal and divide it by the number of coalitions. All right, that of sequential coalitions, that is 1/2. or as a decimal 0.5, or as a percent, 50%. All right, so that's for player 1. For player 2, they also are pivotal 3 times out of 6 possible sequential coalitions. So they have the same, oh, there's supposed to be equal sign here. They've got the same amount of power according to the Shapley-Shubik Power Index. And player 3 has 0. Player 3 is pivotal in 0 of the 6 possible coalitions. Now, 0 divided by 6 is 0, right? That's something that's always, some people are confused by that. They're like, wait a minute, what is that? But if you go to your calculator and you do 0 divided by 6, it will tell you 0, right? So, I mean, it doesn't matter, like, say you have a pizza and you divide it up into 6 parts and you take no parts, you don't take any pieces. How many pieces do you have? You have 0 pieces, right? So 0 out of 6 is still 0. Now, I think people sometimes confuse it with when you divide by 0, that's a different story. If you take any number, say 6, and divide it by 0, that your calculator will tell you there is an error. This particular error says error divide by 0, right? Some calculators will say something like domain error, or some of them might just say error, right? So you cannot divide by 0, but you can divide into 0, right? Because like we said, like 0 divided by 6 is like saying divide your pizza into 6 pieces and then don't take any of them. You have no pizza, right? But 6 divided by 0 is like divide your pizza into 0 pieces and take 6 of them. That doesn't make any sense, right? It just doesn't make any sense. So you can't divide by 0, but 0 divided by 6 is still 0. So that is 0%, right? So this collection of numbers, right, is the Shapley-Shubik Power Index. So in this particular instance, player 3 has no power. Now, just to review, I'm going to take a look at this voting system. So I'm just zooming in, and I'm just looking right here, right? So notice that there's no dictator, right? And there's no one player who can meet quota all by themselves. What about veto power? Who has veto power? So what does veto power mean again? What does the definition say up here? Veto power. I'm going to find it right here. Here we go. A player has veto power if their support is necessary. Okay, so you need them for the quota to be reached, which means the other people in the system can't reach quota without them. We're talking about the whole system here. Okay. Where are we? No, this bounce off. Oh, we were here. All right. So is there anyone in this weighted voting system whose votes are required to meet quota, meaning they have veto power? And I believe it is player 1. Because look at players 2 and 3. They're together, they only get 30. There's only 32. So they can't reach quota without player 1. So player 1 has veto power. All right. I'm not going to think about critical players, because critical players are about coalitions, and I don't want to do coalitions. I don't want to do like winning coalitions. But there's only 3 players, so it would be easy to do. But I just kind of want to look at that. Now, what about what was I just thinking about? Like, are there any dummies? Oh yeah, that's what I wanted to think about. Are there any dummies in this weighted voting system? Because according to the Shapley-Shubik Power Index, player 3 has no power. So does that mean the player 3 is a dummy? Right? So if player 3 is a dummy, that means that there is no winning coalition in which his votes matter. Right? So, okay, you know what? Now we do have to think about coalitions. But since there's only 3 people, right, there aren't that many in coalitions, and there aren't that many winning coalitions. So I am actually just going to quickly write down the winning coalitions here. So P1 This is just review, right? So if you don't want to review what we did in earlier, you don't have to. You can stop the video right here, but I'm reviewing what we did earlier. Player 1, player 2, that's a winning coalition, right? Because that's 37. Okay. Player 1 and player 3, that's not winning, that's only 35. Player 2 and player 3, see, look here. The only winning coalition is and then there's also the whole one, right? Which I was like, it doesn't really matter. It's almost the same, right? So these are the two winning coalitions. But notice, right, in any way, player 1 and player 2 win without player 3. So player 3 is technically a dummy, right? So the fact that player 3 is a dummy is reflected in this Shapley-Shubik Power Index, where we see that he has no power. Now, so you would think that if you found the Bonsoff Power Index, that he would also have no power there. That's an interesting exercise. You should try that and see if that is true. All right, and that is the very last video in the weighted voting. Let me know if you preferred it like broken up like this with lots of little different videos, or if you would rather me have just made one long video that you could, skip around in. I'm thinking that you're going to like the little videos because then you, it's more focused. And like, if you want to go back and watch the examples for Bonsoff Power, you know exactly where to go. You don't have to scroll through the video. That's what I'm anticipating, but let me know. All right. I will see you later.